Hi everyone, so what we've got here is the insides of an EU20i Honda inverter generator. So it's got a few problems with it. Most likely the main board for it is ruined, something's wrong with it, because that's led to the windings, well, one of the windings in the generator unit becoming burned. It's just all charred and basically ruined. I think one of the phases has gone. So the engine's still good, and my intention for this project is to rewind the stator coils in the generator and just basically make it to output I reckon roughly 24 volts, maybe a bit more, because I want to use this for charging my off-grid battery bank if necessary. Now obviously the controller that I'm going to design for it, the way it's going to work is it will allow this generator to act as a starter motor also, so it will be just like the range extender in a BMW i3, and I'm sure that I can make a VESC based motor controller which would allow that idea to be possible. And these engines are good because they're, as far as I know, they're pretty quiet. The other issue is it's leaking oil very slowly through the oil sensor, which Honda have so very stupidly put on the bottom of the engine. It's actually right down here, that wire coming out the bottom, which is just all soaked in oil. What a stupid place to put it. Along with their totally unrepairable design. This is just ridiculous. I absolutely hate stuff like this. At least all the products I develop are not absolutely potted in epoxy, and they're designed to be repairable to an extent. But that's just how it goes, unfortunately. So if I was using this to charge my off-grid battery banks, obviously I'd just weld an extension on this exhaust, route that outside, and then all the waste heat off this engine would just heat the house. And I'd take the necessary precautions like putting a carbon monoxide detector nearby. I'm sure you could get carbon monoxide sensor modules for Arduino or whatever, and if it senses that there's carbon monoxide in the air near the engine, I'll just switch it off immediately. And finally, I'm going to run it on propane because petrol is just disgusting and it stinks and it mixes with the engine oil. The only thing with propane is though, it could burn the valves in the engine I think if you run it too rich or too lean. Not too sure about that, seems to be pretty mixed opinions. Most engines that are designed to run on natural gas and propane and stuff, they've actually got hardened valves and seats, but this engine is a Honda GX100, so I'm not sure if you can actually buy hardened valves and seats for it or not. But I think if the worst comes to the worst, I could maybe just get a new head for it in a few years if necessary. But as you can see, it's a really interestingly designed compact unit, and the first thing I'm going to have to do is battle with this huge nut on here to get this flywheel removed. That's going to be an absolute pain. I don't have the belt thing that you can put around it. Another thing to consider actually is the ignition system as well. If I find the ignition coil for it, which is over here, if you look at this, you can see that the coil, it's just like a normal ignition coil where there's the spinning flywheel underneath it with the magnet which generates the spark, but it seems to have been mounted up here away from the flywheel, and the pulse comes down the grounding wire. So this isn't actually the grounding wire in this application. A pulse actually comes from the main circuit board. So I reckon, well, you can see the ignition pickup there, so I reckon I could use a CDI module, possibly a DC CDI module, one of those things for a Chinese scooter or whatever, and that might actually work. If not, I'm going to have to figure out how to design an ignition system, which is just absolutely brilliant. But never mind. So I think I'll get that flywheel off, I'll get all the electrics out of the way, and I'm just going to pressure wash everything because it's absolutely filthy. So I don't like working on dirty stuff. Obviously I want everything to be nice and clean, and we'll need to seal up the oil issue and get that sorted out. And the servo, this is the carburetor. I've already had a go at this to convert it to propane. I've just drilled an 8mm hole in there where one of the petrol tubes was, and I'll just have to find the right kind of epoxy or something, and I'll just put a hose barb in there. So that's drilled right through into where the float bowl and everything would have been. And I've just removed everything from the stem, and we've just got a hole in the side, and it just goes up into the venturi area. So hopefully that should work. This to me just looks like some standard stepper motor, so these can be controlled via Arduino normally. I'm not sure how you could control that with VESC. It could probably be done, I reckon. Need quite a lot of scripting or extra coding, but there are spare pins on the chips that are used in the VESC. Usually there's a few pins spare, so I may be able to do something, but my C programming is not brilliant. So as you can see in here, one of the phases has just been absolutely fried, but luckily this looks like it will be easy enough to rewind. I'll just have to make sure obviously to do it exactly the way it was wound, and then just wind it with fewer turns of thicker wire, or just double up the wires like they do in some cases, and then that should be fine for my generator solution. But I would say that's pretty well burned in some places. One of them is just absolutely melted, as you can see here. So that just can't be used like that. Well, I'm getting rather creative now, so in order to get this flywheel off, I've just made up a special tool, and all I need to do is just bolt these two together, or I might actually weld it, but I reckon we could go with bolting just now, and that should hopefully make this really nice and strong and allow me to get the flywheel off. I've come up with this idea, big thick steel tool. I've threaded a hole through it, and now I've got it bolted down onto the rotor here, so I'm just going to start gently tightening this up, and hopefully it's going to pop off. Keyword being hopefully. Just making sure I'm not damaging it. And that is extreme. That is unbelievable. The amount of force that's going through that, and it's still not coming off. I think it's at the point where even a flywheel puller tool wouldn't even get that off. Problem with a puller is there's nowhere to actually get it in without cutting pieces off the engine. You get one in there, you get one leg of it in there, but you're kind of stuffed for there. That is insane. Yep. Something's just snapped there. I don't know what, but something's just given up. Well, that snapping noise was actually the flywheel coming off, so I've just got to try and fight the magnets. Yeah, it's absolute nightmare of a thing. Unbelievable. Well, there we go. There's our stator there. Don't know if I should pressure wash the magnets or not. As you can see, obviously not neodymium, but I don't know. That's the oil sensor. Need to try and fix the leak on that. Yeah, here we go. Just a better view of that stator coil there. So it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8 wires coming out of this, which is a very weird arrangement. Obviously, after I've wound this, there will only just be possibly 3 or 6 wires coming out of it. I'm going to design it so I'm going to try and wind it so that it can be wound and so you can select between star and delta. So a major breakthrough has been made with the ignition setup. So this is just some generic DC CDI unit which came with an ignition coil. So the way this works is you just supply it with 12 volts and I've wired it up so that the kill is not connected. The amount of hassle I had with this, I had both of these connected to 12 volts. Turns out when you supply 12 volts to the kill, this is actually where the kill switch is connected, it switches the thing off and you get no spark. So the way we've got it wired is, you can find diagrams for these online. I've wired it exactly as it shows online to wire a DC CDI ignition unit. So we've got the pickup here, as you can see. Now watch what happens when I move the magnet near the pickup, the magnet on the flywheel. So I'll just turn this now. We're getting a spark. So that's pretty good. It works just exactly like you'd wire it if it was on a scooter. So that's ignition sorted out. Now I need to get the carburetor on it and see if it will run. But you can tell this is working because you can actually hear a sort of ticking sound coming from it when it's switched on and just sort of idle and do nothing. But it looks like the timing of this is adjustable, so that's really good, which is probably beneficial for running this thing on propane, because I think you need to advance the timing a little bit. Shouldn't need to worry about regapping the spark plug, because I'd imagine this gives a fairly powerful spark, although to me it doesn't seem that powerful really. But anyway, we'll give it a try. Okay, I'm pretty much ready to do a test now. So this is actually the original ignition unit which is in the generator. It's actually housed in the front panel, so that explains why when the main inverter board goes, the engine will still run, because the ignition system is separate. But I don't know how to reverse engineer this one to make it work, and it's probably not really worth my while, because this is probably worth about £35–40 anyway. So I'm just going to sell this, whereas this cheap ignition unit here, I think it was £12 when I got it, so much better and more cost effective just to use this. And the ignition coil is also compatible with the CDI. Remember, it's a DC CDI that you need, and then you just use the frame as the coil ground. That's obviously the trigger wire for the coil, so the original coil will work just fine. Well, we'll see when I take this outside and test it. And before I do that, the other thing worth noting is this pipe coming out here. That was for the original fuel pump. That just sort of creates a pulsing effect to make the fuel pump work. So I'm just going to cap this off, because that's not needed anymore. There's going to be no option to run this thing on petrol. It'll just be propane or natural gas. But when I test it, I'm going to run it on natural gas. Well, there's a slight improvement perhaps. Okay, so as you saw, it did run quite rough at times, but I just had to play about with the choke and the throttle a bit. I was just manually adjusting it, obviously, and it actually worked not too bad. It idled quite slowly, which is fine. So the next project for me to get on with is rewinding the burnt out stator. That's going to be quite a difficult one, so I'm going to have to figure out what size wire to use, and I'll need to decide on that. It's going to be a bit, I think it's going to be a bit difficult to decide what size, but I'll go with something anyway. And if it turns out that the voltage is too low, the way VESC works anyway is it can actually boost up the voltage using very clever PWM techniques that I don't quite understand, but so it's not really going to be that much of a problem. But anyway, I think the project has went quite well, and the saving grace of the whole thing really was this cheap DC CDI module. So all you need really is one of those, and you could get an EU20i or any inverter generator engine, I'd imagine, just running without the original control system.